Hi guys and ladies, welcome back to episode number 9. My name is SMMEs. This episode number 9, we're going to be talking about the different data types. It took me a while to understand the different data types, and it was only when I did my honors that I understand that data behaves differently, and all of that depends on what data types you're working with. Some data types can work together, others cannot work together. And on here, we're just going to look at what normally people are telling us versus what the rest of the database data types should be handled. And all of this is going to happen just after our theme song. So stay tuned. I've battled with different data types for a while, especially when I was a novice analyst. And it's quite funny because it took me a couple of years, and it was only in 2016 when I did my honors that I fully grasped what I had found out, but I didn't have the words for it. That there are different data types that behaves differently. And this is quite crucial, especially when you start with your analysis, and it also hinders or it enables your data interpretation accordingly. So the way when you start, you must just as you start your analysis, I normally start by looking at what is available, what types of data is available, then only then do I channel the analysis towards the best use of the data that's available to me. So the best common one that we normally talk about when you're talking about different data types, people will tell you about decimals or doubles, as you see it when you store it in a database, or integers, or whole numbers. They'll tell you that it's another data type. Percentages, because as much as they look like integers when you store them on SQL, it's only when you're presenting them that you have to say, oh, hang on a second, we're actually doing percentages here. When we get a variance between percentages, now we call them basis points and not just normal variance. Date formatted data types, which is the one that it looks quite funny when you store it into a database. It looks like just random numbers, 5-digit or 6-digit numbers, just random numbers. It's only when you're presenting it that you realize, oh, it's actually a date. The time formatted ones also looks quite weird when you store it, unless if you do it as a text. But as you store them, they look very weird. But it's only when you reformat them into the timestamp that you realize that, oh, actually, it's telling me at what time was this captured. The other one is a combination of both the date and the time, is called the date time formatting, where it takes today's date and the time that I'm making this recording and then puts it together. But also where it gets stored differently compared to how you see it with your naked eye. The text one, which is the one that's quite common that we can interpret and we can read, but there are some points where when it's like CSV or comma delimited, that we might battle a little bit to say, where does the sentence start, where does it stop? It all depends on how you delimitate it. And the other one is location based. Location based also looks like weird random numbers. You can mistake it for an integer, but you might find out that it is actually a location, a geographical location that column is telling you about. Probably could be the location of your branch or the location of where your kiosk normally gets stored. But if you mistaken it, you might mistaken that as the sales numbers. But you are, just by looking at the data type, you can tell that, oh, this is like a data or this is like a location. The last one is Boolean. So Boolean, when you are looking at it, it's the one that gives you ones and zeros. It's a yes or no, or it is a true or false, or one of those that gives you is binary in a way. They get stored more or less the same into the database. It is only when you interpret it to the other people that you realize that, oh, hang on a second. The, the, the slide is talking about how many people said true, how many people said false. I cannot put in yes and no's in my interpretation or in the graph. I have to actually reconvert that into true or false type of a thing. So most of us, we talk about this different data types and we stop it here. And mostly is because of what our customers are looking from us, our main core, our X core. They'll tell us, can you give us a slide that looks this way? And you can do quite well if you just give them what they want. There's nothing wrong about it. There's no harm done. But once you understand the limitation of where you can take your data, you now realize that actually you can give out more. So for this episode, I just want us to explore 4 other different types. So the one that I've spoken about will combine most of them as the first type, which is the numeric data. It could be your decimal, your integers, your percentages. You name them. We put in them as one type, which is numeric type of data. And then the second one is categorical data, where you are now doing into different categories. What does this data tell me? Once you see one type of data, it means there's another category of another. So we call this normally normal, nominal, or ordinal type of data. Both of them falls under categories. It all depends on what type of categories are you dealing with. The third one is the text space that we all know about. It's where we can store our text messages, we store our email communication as text, and even our tweets. We can store them as text message, and then we can do nice things about it nowadays. And that's where ChatGPT also comes into play. The last one that we're gonna look at is time series data. Time series is the one that actually give us to say that's the one that's quite nicely loved in boardrooms. To say, can you show us the trend analysis? It's where we start to say, but in 5 years, in 17 years, this is how we go. We're also going to explore what is the best way of dealing with time series data. The first one, which is the numeric data. So the numeric data represent the quantitative values, so ones and zeros, like normal, 1, 2, 3, 4, 5, not ones and zeros. Beg your pardon. It represents quantitative values and are further categorized into continuous or discrete data types. So I will explain a little bit about what is a continuous, and what is a discrete data type, just in a little bit. If you understand your numeric and you understand where does it go on, you can further get, benefit into saying, oh, hang on a second, continuous behave this way, discrete behaves this way. And what I'm going to do is I'm going to give you both the positive advantage and disadvantage of both continuous and discrete. So let's start first with the continuous. So continuous numeric data can take any value within a range, and it allows for fractions, also fractional values to come in, like 3/2, 1/2 type of a thing. We do allow that. It's a continuous one. So when you see something like 1/2 versus 2/2, you can categorize it to say, okay, it looks like 1/2 is a half, 2/2 is a complete one, so 2/2 is bigger than 1/2. It's quite sensible that we can do that. It's continuous. Starts with 1, it goes to another range. And the best way to look at this is like when you're looking at temperature. When you go into the news and they tell you today's temperature, and they say today's temperature is going to be 18 degrees Celsius, you can say, oh, 0 to 18, it's okay. But 0 to 40, even if I don't know how hot it is, I now understand that 40 is bigger than 18. So it goes by continuous to say, oh, it goes all the way to 1,000 degrees Celsius, 2,000 degrees Celsius type of thing. So the higher it goes, you in your mind you can already think that it's continuous. When you get the number, it's in relation to whatever the number line looks like. So it's continuous like that. Another one could be height. When I say I am I think I'm 179 centimeter. And then if somebody comes, I think Olerato, my wife, is 160 something, almost, 160 centimeters. If I put those and I say centimeter next to it, you can already, in your mind, visualize that I'm taller than her. Another one could be time. When I say 1 o'clock versus when you say 4 o'clock, you already can see the difference because there's already a range within it. So that's just continuous side of things. And the best way to handle continuous data is by doing statistical measures like finding what is the mean, what is the median, what is the standard deviation, and that's how you could actually handle your continuous data to find out where's the chunk of the data sitting in. Out of the number line, you might just say we are almost all the data is sitting at the lower end, or all the data is sitting at the higher range. The advantage of using continuous numeric data is that it includes a high level of precision, and it gives you that detailed analysis to tell you that exactly I'm 179 centimeters tall. It tells you exactly how tall I am. So you would know exactly when you see a door frame that says 2 meters long, you'd know that when I'm 179, I'll be able to pass through. So it gives us precision. However, the disadvantage of this is that handling a large number of continuous numbers could be computationally intensive. This is where we start, running for computers or running for something, because it just becomes too much, because you still have to compute all the time to say, is it, what is the variance between the two? The discrete, on the other side, discrete numeric numbers consist of whole numbers and countable values. For instance, if I have just one mic here, if I have 2 mics, it's 1, 2. It doesn't tell you whether it's a lot or not. What we're doing is we're just counting. You have 1 and 2 mics, and that's where it stops there. I have, 1 pair of clothes. I have 1 hoodie on or t-shirt on. It doesn't tell you, is that a lot or not? Even if I come back with, I have no mic at all, it doesn't say it's a good thing or it's a bad thing. It just tells you, it just describes what you have in front of you. So we shouldn't be confusing continuous with discrete. Other data types is just discrete to tell us that we have 500 stores, and it stops there. Because at one point we might be thinking, oh my God, we must get more stores. No, you don't have to. You don't even need to call God's name to bring it into here. It just says that's just the count that we have, 500 stores, full stop. That's just where it goes. Example of this, like I said, it includes also website visits. When people go to your website, doesn't mean that 5,000 views, it's the big number, or 7,000 views, it's a small number. It just quantifying how many views came or visits came to your website. So looking at that, I think statistical measures that looks like, frequency distribution, histograms, and bar charts can actually come quite handy to make you understand where does your distribution looks like. Remember, histogram is just showing you the bars to say how many people have got 1 mic, how many people's got 7 mics, how many people. It just counts frequency of number of mics. If there's 1 mic, it says one mic. If it's 17 people with 2 mics, it says 17, 2. So it just gives you frequency distribution to say that's just how it is. So that when you make a decision, or Exco and Menco make a decision, you can just see the quantity, and that's it. The advantages of this is just ease of interpretation. You can just hear what I'm saying. It just tells you exactly what you're expecting. 2 mics, 3 mics, nothing complicated about that. The disadvantage of using discrete data is that it may lack precision when compared to the continuous data. So it doesn't tell you exactly, is this good or bad? So we might rely heavily on a subject matter expert to tell us, oh, actually 1 mic is horrible, because in actual sense, we're supposed to be getting so many mics to have a podcast. But with a continuous one, it tells you exactly if the number is low or high or whatever type is. Yeah, the second type that we're going to be looking at is called the continuous one. So if you're looking at them, it's not continuous, categorical, I beg your pardon, categorical data type. So the categorical data types shows or represent distinct categories or groups. So it just tells you that, okay, we have one group, you have another group. And I think if you're into politics, especially American politics, it always looks like it's a 2-party type of thing. It's either the red party or the blue party. But in our case, we can have different types of categories. And we have 2 subtypes, like I said earlier. We have nominal or ordinal. So let's just start looking at the nominal categorical data. So nominal categorical data does not have any inherent order or ranking at all. So 1 doesn't mean it's bigger, 2 doesn't mean it is bigger. But this one, remember, it is not numerical. So it's not quantitative, it's qualitative. So it's let's just go on and I'll show you where the difference is. Okay. Example of this includes gender, colors, or product categories. So gender is data. It could be represented either using numbers, which is numeric, but we know that if I'm saying males are 1 and females are 2, doesn't mean that females are greater than males. Or I can come back here and then just write it as it is, males and females, using text. But it doesn't matter how you show it, whether it becomes numerically or it becomes text-based. What you are dealing with is categorical data. So when you're exporting into Excel and Excel starts summing up all the number 2s and it says, oh, you got 42 or 48, Excel is getting it wrong, because this is not a summing game. It is just counting the number of males, or counting the number of females, or just to give out a ratio analysis to say, oh, it looks like in our work area we have more females and less females. Or when you're doing transformational goals, you can start to say we have so many Indian people, so many people of Indian whatever this was called, this dissidents, or whatever the case is, so many black, so many European, whatever the case is. Just giving your categories. It's not saying it's greater or not. So the nice part about it, the advantage is that it makes it very, very easy to interpret, the same as like what we did with the discrete number. It just tells you as it is. It's black or it's not black. It's yellow, it's green, like 7 different type of colors. It just tells you that that's the primary colors. So it's very simple. However, the disadvantage of nominal data is that it cannot be subjected to mathematical operations. So you cannot say color blue is greater than color black. You can't say that. It's blue, it's blue. It's black, it's black. You cannot say, you can't put a variance analysis next to it. So once you get your EXCO, it doesn't matter how many PhDs or MBAs do they have. If they ask you to show a variance analysis on categorical data, the answer is no, it cannot be done. You cannot do that. I know it's not common, but sometimes you can get an odd request, and then when you talk sense, then it'll revert back and say, oh, sorry, I made a mistake. I didn't understand the type of data that you have. Okay, let's go to the ordinal categorical data. The ordinal categorical data has a predefined order or ranking. So and it means that you must go from one to another, meaning that there's more like a hierarchy between the two. An example of this could be maybe educational level. Remember, we have primary school, middle school, high school, university, and professional type of a thing. So when somebody comes to you and say, I finished university, already in your head, you already have a rank. It's categorical. It's categorical to say university, but you know that you have passed primary, you have passed middle school, you have passed high school to get to university. And that becomes your highest degree. But it's all based on different categories. It could be also surveys, also could be that. Remember when they say rate us level of service that you get, it doesn't mean that one is greater than another. It just means that it moves from horrible to greater. It just gives you a ranking of categories. That's where services go in, or service level. Same as the product ratings also. It just means that so many people feel like they belong in this block, not necessarily saying it's a good or a bad thing. It just says so many people feel like a handle could do well on the mic. Others feel like a flying mic could be quite good. Others feel like this way, and that's our product review. The advantages of ordinal data includes the ability to establish relative differences between the data that you are analyzing. So you would know that this is high school, this is university, or this is professional accreditation. You would know exactly, and it gives you that, unlike the discrete one where you know the quantity but you don't know relative. This one is non-numerical, but once I say I finished high school, you know exactly what does it mean and what steps do I still need to do. Okay. However, the disadvantages of this one could include the magnitude of differences between categories may be inaccurately represented. So in this case, say for instance, you have people that jump from primary to middle school, and then there's gaps between others. One went to university or whatever the case is, and you start to ask yourself, how is it a person went to middle school without going into primary? And then you might find out that because of age, they might have been given the opportunity to just start at high school to finish up with their matric because they're already old and senior, compared to starting at primary school. So with all of that, you might make the wrong assumptions because you already have this straight or sequence of events, but you might find out that your data doesn't follow that sequence of events. There might be people that are starting with high school instead of starting with primary because of whatever circumstances that has taken place. Okay, that's just on one side. That's just us looking at the categorical data. The next one is the simple one that we all know is the text data. So the text data is the one where we're getting our social media responses. We're getting nice things, text. What are the people saying? What are they writing about our product? Product reviews that are text-based write to us about it. And this is where it involves stuff like natural language processing, sentimental analysis, and text mining. This is where stuff like GPT-4 would actually come in quite handy because it will be helping us understand the meaning that's hidden behind the data. So GPT-4 started making waves in the year 2022. And then now in 2023, as I'm doing this recording of this, it's being made few changes into it. And then probably by the end of this year, we might be having version 5, which is GPT-5, which might actually be much more precise than this one. You can still store text base on stuff like SQL databases, and you can still work with that, but there are other better ways of handling text data. And the advantage of text analysis includes understanding customer sentiments, identifying trends, and extracting insights. Especially, I'm just thinking about the cloud, wet cloud. Wet cloud will be quite a nice representation of what did most people write about your product. Wet cloud, just look at the word frequency. If I say love, whatever, it doesn't matter how many times I wrote stuff. Just take out the word love and it put it there. With sentiment analysis, it takes each sentence, it's a review from a customer, and it says, is it a positive, is it a negative? And then it groups them together to say, these ones that are positive, the word frequency is product, how it looks. Those one that don't like, the word frequency is service. So it looks like we are good with product, we are bad with service. Text analysis that we can do. The disadvantage of working with text analysis is that it can be challenging due to its complexity and ambiguity. You can just imagine me trying to give you a full review or analysis on your products without me understanding exactly how the whole thing goes. So I can be taken away by people's comments, and I bring it back, and the Menko Exco tells me, no, you totally misunderstood. What are we selling here? We're not selling insurance. We are selling financial services. Although just other people, it's very close. The last one that I want us to look at is the time series one. So the time series one represent observation collected over a sequence. Sequence is a keyword of equally spaced time intervals. So it needs to be sequenced and it needs to be equally spaced. Like, say, for instance, in here, a monthly trend, a quarterly trend, a yearly trend. So we cannot start by saying, okay, we have one observation for last month, another one for a quarter, just put it there, another one for a month or a year, whatever the case is. So your observation cannot have different intervals. So for time series analysis, it needs to be equally. Once you come into a data and you see equally spaced observations, you now know that you're dealing with time series. And this one is quite important, especially when you're dealing with stuff like sales. You have to do this time series. Things like marketing, when you're looking at impressions and article views and stuff like that, I think other data types might represent the department much better. But this one has to do with comparison or variance analysis type of a thing, and how you're growing. It has to do especially with time series analysis. The observation becomes statistically significant when collected over 30 observations. So this is one thing that I realized when I was doing my thesis or my dissertation, my master's dissertation, that for statistics, once you are collecting time series, you must at least have 30 observations so that you can start to do all the fun things like regression and stuff like that. That's where you know that if you don't have 30 observations, it becomes difficult to do predictive analysis. But once you start to have 30 observations, then you can, okay, hang on a second, I can start with predictive analysis, and it's quite nice. So you can do all of this thing in Excel, but I think the best way is there's different tools that are out there that you can actually look at. So the advantages of using time series data includes the ability to identify patterns and make predictions, like I said. The disadvantage is that these data types can be influenced by various factors that from others might be outside of your control, making it susceptible to outliers and anomalies, because now you have a year full of data and 1 or 2 years where you didn't have any data. So that's it, guys and ladies. As far as I'm concerned, understanding the type of data that you're dealing with and knowing exactly how to handle it can actually save yourself impossible tasks, because some of the your customers, be it your management committee or your executive committee, might be coming with impossible tasks, asking impossible questions, while you know that you're sitting with the data that won't be able to represent that. You might be sitting with categorical data, and they want something that tells them about, can we see the trend? But you might be sitting around and say, no, we don't collect data that's based on trend. We collect data whenever we have a marketing campaign. We collect all the data about that marketing campaign, and then a few months passes, another marketing campaign. A year passes, another marketing campaign. So we have categorical data. We don't have a trend analysis, and we can't just force it in. Thanks, guys and ladies, for joining me in this episode number 9. I'll see you again in episode number 10. I hope what we discussed here in episode number 9 quite helped you out to understand what you can say yes to when you get requests from management community or not, and what you can tell them is possible and what you can tell them is not possible based on the data that we've been collecting. So see you in episode number 10. Just stay tuned for another episode.